So here we have the problem to evaluate sine of e to the x times cosine x. The point of this problem is that sometimes you have to combine rules. What we have here is we clearly have a composite function. In other words, we have an inner function, but the inner function itself is a product of two other functions. So let us evaluate this. Again, what we want to do is we want to work from the outside in. We know the derivative of sine is cosine, so we're going to take the cosine of whatever's in the inside and then multiply by the derivative of the inside. So this is going to equal cosine of e to the x cosine x, and then times the derivative of the inside, which is the derivative of e to the x cosine x. So all we have to do is find that derivative, and that's going to be cosine e to the x cosine x times, we're going to find this derivative by the product rule, so that's going to be e to the x times negative sine x, and then plus the derivative of e to the x is just e to the x times cosine x. That's just doing the product rule. So that's how we would find that derivative, like that. So let's do another example where you have to combine different rules. What I have is some chain rule problems inside a quotient rule. So h of x is defined as the quotient of two functions. I'm actually going to use f and g to be the quotient. In other words, we're going to say that h of x is equal to f of x over g of x. So that we're going to use f and g for the quotient rule symbols, and then we're going to use the chain rule for both the numerator and denominator in this quotient function. So let's say f of x is equal to sine of x squared plus 1, and g of x is equal to ln of x plus 2 times e to the x. So now f prime of x, we can do this by the chain rule. This is just an outer inner situation, a straight one like that. So it's going to be cosine of x squared plus 1 times the derivative of the inside, which is 2x. And then we have g prime of x, ln of x plus 2. I'm going to need a little more space for this because this is actually a pretty complicated derivative. G prime of x equals, so we have ln of x plus 2 is, actually I'm going to write that. That's going to be ln of x plus 2 times the derivative of e to the x, which is just e to the x, and then plus the derivative of ln of x plus 2 is 1 over x plus 2 times the derivative of x plus 2 is just 1, right? Because it's going to be 1 plus 0, so that's 1, and then times e to the x. So this actually equals, let's see, I'm going to actually factor out the e to the x and say this equals e to the x ln of x plus 2 plus 1 over x plus 2. So that's the derivative g prime. All right, so just to remind ourselves where it normally goes, it goes there. Okay, so now I have f and g in the quotient rule, and I simply need to apply the quotient rule. Recall that then h of x is going to equal g f prime minus f g prime over g squared. So that's going to come out to, let's see, that's going to be ln x plus 2 times e to the x. So gf prime, and then times cosine x squared plus 1 times 2x. So that's gf prime minus fg prime is sine x squared plus 1 times e to the x ln x plus 2 plus 1 over x plus 2, all over in the very biggest fraction division sign that you've ever seen. I now have to square g. G is ln x plus 2 times e to the x, which is ln x plus 2 times e to the x, and we just square that. So there you go. That's just a derivative for just an ordinary everyday function, the kind that kindergarteners all across America are encountering right now.